Oh, hi. Hello, and welcome to this session on the Practical Machine Learning course. We are super excited to have you join us today. My name is Stephen Oladele, and I'll be your host for the next 1, 2 or so minutes, introducing you to this particular section and what you will learn. All right, so let's just dive right in. Why are you here today? So, in a nutshell, you're here to learn about best practices for model deployment and gain new information on how to go about deploying machine learning models. And you're going to be getting all these information from Robert Jung, who is the chief data scientist at Bassus, as well as a Google developer expert in machine learning. In fact, the first in Sub-Saharan Africa. More on that later. All right, so we want you to get the most out of the session. So we kind of give you advice on how you can go around, whether it's a workshop or it's a session, just how you can get the best out of it. If it's a workshop, of course, you need to get hands-on. You need to make sure that you're practicing just as your facilitator is practicing. But this is more so going to be a talk session whereby you're going to be learning best practices from the chief data scientist of Bassus, and you're also going to be gaining new knowledge on how you can go about model deployment, how you can, the pitfalls you can avoid. So the advice we typically give for such session is like, you should take notes of the terms you don't understand. So everything might not make sense to you. It's all fine. It's on our YouTube channel, and I'm not sure we're going to be bringing it down anytime soon. So you can always come back to the session and and go over it again. So at first time, you need to take notes as much as you can. Take notes. It's a premiere. If you're watching it as a premiere, it's a premiere. You can always pause, reduce the speed of the video. That's why, of course, it's a recorded session, so you can always pause, go back to things you don't understand, and take notes, because taking notes that you revisit are actually very important for recall. The next thing is you research on the terms you've taken note of that you don't understand. Engage with the community on social media, Twitter, Reddit, wherever you're. They are, of course, they're mostly on Twitter and Reddit. You ask questions from experts and other members of the general machine learning community. It's a really an amazing community. So take home best practices and good methodologies as much as you can. These are the things that really help you get the most out of sessions like this. Best practices, good methodologies, taking notes of terms you don't understand will help you a lot. All right. So what you learn in this session? So you're going to be learning. You're going to be getting an overview. So the reason why we tell you what you learn in this session is so that when you eventually finish this session, you can come back to this particular slide. You can come back to this particular portion of the video and look at, have I really gained more ground in these key points out here? Have I learned an overview of model deployment, the model deployment landscape? Do I know the most recommended approaches for various model building workflows? Do I know why data engineering is an essential skill for model deployment for me as a data scientist or ML engineer? And of course, how do I know how model deployment is now done practically or applied in an applied sense in the industry? And do I really have key best practices for model deployment? And do I know the pitfalls to avoid? So you can always come back to this particular side of the video and come and assess yourself pretty much. So before we go on, just get to know us. So we are Port Harcourt School of AI. Of course, you can find more about, you can learn more about us at Port Harcourt School of AI.org. And pretty much what we try to do is we try to make a world-class AI and data science education and technology accessible for anybody interested at all. So we actually are in Port Harcourt, Rivers State, or we're kind of making sure that everything we are doing is not just accessible to the people of Port Harcourt City or River State, or generally outside of River State as well. Generally, just making sure that world-class AI education from experts, practitioners, researchers, engineers are very, very accessible. But as well as the technologies themselves, they're accessible to anybody interested. And we try to make sure that everything we do is centered around these things. And this is why we try to bring world-class practitioners to make sure that you can get best practices on how to do things, and this technology is accessible for you to learn. All right, so while we do this, of course, it's just pretty much making sure that we make sure that these technologies are accessible. We're also making sure that the place where we are in River State, it's the businesses, institutions, government policies, and all of these things are very, very data driven. and we're still at the very, very scratch of this. We've not really done so much with this, for slowly but surely, I think we'll get to the point of making River State a hub of collaborative and competent AI talents, data-driven AI talents. Yeah. All right. So what we do, of course, we try to make AI education accessible. So you can really check us out on Twitter and so on. So let me just go quickly. So our story so far, you can read our report here. On Twitter, we're very active, so you can follow us on Twitter. You can also go to our website to visit our blog and see what we've been doing so far and all of those things. All right. So, and other things also, you can also consider supporting the community. We try to provide value by looking for the best books, looking for the best courses for you to take, looking for the best people for you to connect with. Looking for the best jobs and opportunities for you to connect with. So you can stay in touch with us, and you can also check the links in the description for links to books that you can buy and read and support the community through, because we are an affiliate with Amazon, because this is how we make sure that we improve on our work and try to make sure everything is still free and accessible for the general community. All right. So, but this is about you, because it's not really about the company. It's not really about us organizing this time. It's not really about we serving. It's about you and what you gain from, the service we're rendering. And there's this amazing quote we have: successful communities are those that put their members first in every plan. And that's the exciting thing. So where you should go from here, what we expect you to do after the session is, you join an AI learning community in your region. If you don't have one, search for one. If you're in Nigeria, Data Science Nigeria, Port Harcourt School of AI Saturdays. If you're away from Nigeria, GDE, most likely. Any of it, just search on Google. Google is your best friend. Go if you use that, and so on. Just make sure you join an AI learning community. It's quite important you do, so that you can be able to gain value from the community, as well as give back if you have, and of course you must have value to give back to the community as well. So of course you should explore more on the topic for today's session. So we're going to be leaving some various links in the description. You can explore more, use your search engines to see how you can learn more about model deployment, connect with the facilitator for today to see how you can get more links on how you can explore this fascinating field. Sorry about that. All right, get started. If you haven't started ML, of course, it's a requirement that you start ML before the session. But if you haven't started ML, get started. There's nothing like you can be a data scientist, according to Vangelis Odin, one of our amazing guest facilitators from the past. You can be a data scientist. As much as you can, get started. Right. I mean, if we can have more people who get started in this space and are very keen on making progress in this space and impacting in this space, I mean, we will have a better African continent and generally the world. So ask questions on Twitter. Twitter is an amazing ML AI community. The AI community, ML community is amazing on Twitter. You can pretty much reach almost any expert you want on Twitter. Ask questions, get in touch with the experts. The general AI community members are really receptive and amazing. They are at least majority of them. Get on Twitter and ask questions. All right. So if you want to join our community, you can join us on Slack. We are still working on making sure that we have a strategy for Slack and how people can effectively communicate with Slack. That's why, but you can still join it, and you can join our Slack channel using this link. Of course, once we get active, you'll get up and running with the community, and also follow us on Twitter. We post most of our activities on Twitter as well. We're very active on there because that's where the ML community, we believe the ML and AI community is generally active. All right, so you get to know today's facilitator. And today's facilitator is Robert John. He's a chief data scientist at VASIS and also a Google developer expert in cloud technologies and the first Google developer expert in Sub-Saharan Africa for machine learning. Amazing person. All right, so he's going to be talking to us about getting started with model deployment, very accessible for practitioners and, very accessible for people who are beginning the space for, built models already and are thinking of how those models can be used in the real world. And you can come to Robert's LinkedIn profile. Yeah, so you can come to Robert's LinkedIn profile. You see that he's also a certified Google Cloud certified data engineer. Of course, then you must know that he knows what he's saying when he's talking about model deployment. He's also I think you can come and look at his experience pretty much on his LinkedIn page. So he's Robert John. You can come and look at his experience on LinkedIn and get to know his experience and see his journey yourself. And if it's something you really want to emulate or you want to create your own path, whatever, you go. So we are super excited to have Robert once again. So just a side note, we have experts. If you're watching this on our YouTube channel, of course, which you expect. So we have various experts who have given talks before, and we have various experts who are going to give talks in the future. So you have the next expert, Emmanuel Bakare. You have Ankur A. Patel, Lynn Langate, Evaristius, and some other experts here as well. So Professor Julia, and let me just okay, so Professor Julie and some other experts and practitioners in the space. So you can always get back to our YouTube channel and access it. This is how we are trying to make world-class AI and data education, data science education, and technology accessible for our community, right? So without further ado, of course, because I've taken so much of your time, so without further ado, we'll jump right to Robert's session. So Robert, you can take the floor now. Thank you.
Welcome to this session on getting TensorFlow models into production. My name is Robert John. I am a Google developer expert for machine learning and the Google Cloud Platform. So quickly, I'm going to start with why do we make use of TensorFlow? So TensorFlow is a numerical computation library. There are other numerical computation libraries such as NumPy, scikit-learn, and PyTorch. And you could use any of these numerical computation libraries for training machine learning models, amongst other things. So numerical computation libraries are not just for machine learning. Now, we're going to focus on TensorFlow in this talk. And when you make use of TensorFlow for training your models, it could be for any of a number of reasons. It could be simply because you're learning, or for research, or prototyping, or for production. TensorFlow itself provides both low-level and high-level APIs. Low-level APIs could be used for research purposes or for learning. They're also used in prototyping when people want to have some fine-grained control over how their models behave, how they train the models, what sort of learning rate schedule is applied during training. However, for production, high-level APIs should be used. And that's because in production, you need to have some sort of standardization. And that comes with the high-level APIs. But that's also because there are some issues that you need to handle, some situations that you need to handle. So machine learning in production is kind of like software engineering in production. It's one thing to write a library, for instance, or to write an application. It's another thing to take the application and make it something that, say, 10,000 people or 100,000 people can use. So if you come from the software engineering perspective, you're going to be looking at things like what sort of production pipelines do you have in place? Are you making use of something like GitHub? Do you have continuous integration and continuous deployment in place? Do you have tests in place and those sorts of things? Now, clearly, when you're learning machine learning, we do not come across those types of topics. So we do not talk about running unit tests in machine learning, for example, or we do not talk about scaling production deployments. So before we get to production, we'll talk about what low-level APIs are in TensorFlow. And really, the low-level APIs give you an implementation of your mathematical constructs. So what that means is in research, for example, or in prototyping, you might be implementing some mathematical equation. And so you need to convert that mathematical equation into your Python code, for example. And so you'll have things like constants and variables that you're dealing with. We know that you're doing linear algebra, so you're going to be doing matrix multiplication. There's a whole host of APIs for this. However, when you start to look at the high-level APIs, there are two popular high-level APIs. There are really more than two. There are two popular high-level APIs in TensorFlow. One is called the Keras API, and the other is called the Estimator API. The Keras API lets you deal with either sequential models or the functional API, which is defined by keras.model. The estimators give you what are called pre-canned estimators, and some of these are things like linear regressor, linear classifier, and combined regressors and classifiers. And there's also just an estimator class that you can extend to do all sorts of complicated things. You might want to use it to do k-nearest neighbor regression, for instance, or some sort of clustering algorithm. So before you get to production, you clearly have to prototype your machine learning model. And in prototyping, again, when you use the high-level API, you'll start by importing data. You can't have a machine learning model without data. So clearly we start by importing data, and usually you'll make use of the pandas library to import your data. Your data might be stored as a CSV. Pandas will read it. Pandas will read a myriad of data formats, not just CSV. So you start by importing your data into a data frame, which you call DF, for example. The next thing you need to do is create feature columns. So your data is made up of features and labels. You're trying to predict your labels, but you have to deal with your features. So you create your feature columns and you put that into a variable, which we call feats here on the screen. Now, when you deal with estimators, you will need to create input functions. And so we have a training input function, which you need to define. And what that does is it provides the data during training to your model. There's also a validation input function and a prediction input function. Once you define all of these, you're then able to go ahead and create your estimator. So in this example on the screen, what we're doing is we're creating a linear regression model. So our estimator is an instance of tf.estimator.linearregressor. And recall the feature columns which we created at the beginning. We specify them as a parameter. We also need to specify an optimizer. Now you need to train your estimator. And to train your estimator, you call model.train, or estimator.train in this case, and you specify your input function. Now, once you're done training a model, what's the point of a model without model evaluation? So you can go ahead and evaluate your model using the snippet on the screen, and then you can go ahead and run prediction again using the code on the screen. So all of this is fine for prototyping, but how exactly are users going to make use of all of this? So are you going to take your model and then slap some sort of say a Flask endpoint in front of the model, and then take the inputs from the Flask endpoint and call your model and send back your response? Well, you could do that, but does it scale? It doesn't scale, right? So you need to worry about how exactly you would make that scale. Now, to put it in production, you have a number of options. So clearly, yeah, you could use the Flask API endpoint option, but then what that means is you need to set up your server. You need to worry about what sort of traffic you're going to be dealing with. And if you're conversant with software engineering, then you should also be conversant with the field of developer operations, what is frequently called DevOps. And so the people in DevOps are concerned with, hey, you've given us this application, you've told us to put a web server in front of it, but we have to deal with all sorts of concerns. So today, 100 people try to use this thing, it's working. We wake up tomorrow and somebody tweeted about it, it's suddenly popular, 1,000 people are trying to access it, the web server is bouncing people back, people are getting timeouts, all sorts of issues. So DevOps issues. Now, if you're not using Flask and setting up your web server and other things, what are the other alternatives? One alternative that TensorFlow provides is called TF serving. TF serving is popularly provided as a Docker container. Now, that comes with its own new problem. Do you know how to deploy Docker containers? What does it take to deploy Docker containers? How do you scale Docker containers? New class of problems. Are you going to set up a compute cluster? Are you going to set up a Kubernetes cluster? New nightmare. I mean, I'm an ML engineer. What do I want to deal with, right? How many of these things? It's like one of these nightmare recruitment posts where they say we need a graphics designer, but you should also be able to write Vue and Angular and write Node.js and Python and Java and Scala. You should understand databases, minimum. You should be able to work with this or database and that database and blah blah blah. Like, seriously? So how do we work with this in production without going insane? So on the Google Cloud platform, there is something called the AI platform. It's a section on the Google Cloud platform. So the Google Cloud platform, being a cloud platform, has a lot of things. It provides compute resources, both managed and the ones that you need to manage on your own, and the ones that the platform will manage for you. There are database and storage resources, there's security resources, networking resources, and then there's a machine learning section, which is called the AI platform. Now, the AI platform is actually an implementation of TF serving, but it's fully managed, meaning that you don't need to go and get the Docker container, set up your Kubernetes cluster, and worry about scaling things up or down. So in order to work with it in production, you're going to need to do something. You still need your input functions, but in this case, you're going to need something called a serving input function. You're also going to need a training spec and an eval spec, and you're going to need something called an exporter, and then you're going to need a train and evaluate function. So while previously we had a training step and then we had an evaluation step, these two get combined. Now, the essence of this is, again, one problem that we have is when we're prototyping, we tend to do prototyping on our personal systems. Or, I mean, if you're advanced, you might set up a virtual machine on the internet and push training onto that virtual machine. But how do you actually do this sort of remote training? When you're evaluating, you might work with small data sets, maybe a few 100,000 lines of data if you're dealing with tabular data, or if you're dealing with images, maybe a few thousand images at best. But how do you do training on millions of rows of data, on hundreds of thousands or even millions of images? Clearly, you're not going to do that on your laptop or on your desktop. If you work for an academic institution, you might have some really large servers with GPUs. But if you do not, then how do you do that training on the cloud? Again, the AI platform lets you do that. So with all of these requirements, let's go ahead and look at how you would change your code to implement these requirements so that you can do all that. So now you need to define a serving input function. And so your serving input function will have your feature placeholders. And so your feature placeholders are the things that will take your parameters that will be passed into your model. You define your features, and your features will take your feature placeholders and will expand them, and they will create keys and tensors out of those. And then you'll return your serving input function. Your serving input function will take features and feature placeholders. Now you'll define a training spec, And your training spec will simply say, this is my input function, and my input function is defined by this, something like, read my data set in parallel. And the reason why it needs to be able to read in parallel is, remember that you might be using a computing cluster, you might be using the cloud to do your training. You also define the maximum steps for which you want to train, because again, it's machine learning. Machine learning is about looking over your data multiple times. How many epochs are you training for, right? So maximum steps will now say, here's how many steps you should train for before handing back my trained model. You'll also define an evaluation spec, and your evaluation spec will also have an input function, but this is the data that you'll use for evaluating your model as you train. Usually for validation, you will go over the data just once, so number of steps will be none. Start delay sex, you can set it, which is just saying wait for this duration after training has started before you start trying to evaluate my model. Right, so start evaluating after this number of seconds. And then throttle seconds is saying as training is going on, this is the period at which I want you to evaluate my model. So where throttle sex equals 10, what we're saying is every 10 seconds evaluate my model. Now you also need something called an exporter, and we're going to see that next. So the exporter is a class that will export your model using your serving input function as an input. So what that does is, when you have your model finally, your model utilizes your serving input function specification to get data in. Right. So once you have those, you need to define train and evaluate. So train and evaluate is now one function that performs training and evaluation. And you will specify things like your output directory, which is where your final model will be stored, and also the number of training steps, so how long you want to train this model for. And so inside of this function, you will define your estimator. So previously we defined our estimator outside, and then we ran our training and then performed our evaluation, but now we specify all that in here. So we just say, create a linear regression model. We specify the model directory where we want this to be stored. Now there's a secret to this output directory. The output directory could be on your system if you are training the model locally, which you would want to do just to be sure that there are no errors in everything that you've done on a really small subset of your data. But the output directory could also be a cloud bucket. And so what happens here is, when you do cloud training, you will specify a cloud bucket for your model to be held in. So you also need to specify your feature columns, because how else is the estimator going to know what your data structure looks like? So we previously defined training specs, evaluation specs, and exporters. So you'll specify them in here, and then you will call tf.estimator.train and evaluate, which is the function that we defined, and you will pass in your estimator, and you pass in your training spec and your evaluation spec, right? So once you do that, if you run that, you will get your data in a folder such as this. If you run it locally, you will get in that folder where you have your model, you will have a new folder called export, and inside of it you'll have a folder called exporter. So when you define your exporter, you specified a path. So that path was called exporter. It could have been called model. And then you will have a randomly generated number. So every time you run model training, you will get a new number generated. And so inside of that, you will have a saved model.pb, and pb is short for protobuffer. So that is your saved model. That is your TensorFlow model as a protobuffer. So this is what your output will look like. Now we've defined the model for our new scenario, which is our production scenario. How do we actually perform that model training now? So we're going to get to that shortly, but essentially once you have that your model in there, you're able to use these two Google Cloud commands. gsutil-mb will create a bucket. So remember the bucket on the cloud where we said you could drop your model. Now, if you create your model locally, you can use gsutil make bucket, and you can create a bucket in the cloud, and then you can use gsutil cp to copy your entire folder. So -r is a recursive copy. So these are just Linux commands. gsutil copy recursively this folder, everything inside of exporter, to my bucket. Or you can use the Google Cloud Storage console. So you just go to Google Cloud Storage, create a bucket, and then upload the entire folder. The command line lets you do a multi-threaded copy, so it's usually much faster than doing it from the console. But you can do it from the console, no issues there. Now, how would you go ahead and take your trained model and deploy it? So you can deploy your trained model using this command, gcloud AI platform models create. And I'll advise that you go and take a look at the documentation for gcloud AI platform, because it will let you do your model training. It will let you test out your model, and it will let you deploy your model. So what we're seeing here is your model deployment, gcloud AI platform models create. What this will do is it will go into AI platform. It will go into that TF serving application, and it will create a model for you. Now you need to specify the region where you want this to be created, because Google Cloud works with regions. So you need to specify your region, and your region is just the closest location to your users. For us in Nigeria, the closest region is Europe, but it's fine if you use a US region as well. So you need to create a model, and then you need versions. The reason why you deal with versions is, say you create a model to predict demand on your e-commerce website. That model will get stale eventually. So you need to have multiple versions of that model, meaning that you need to keep taking your data and creating models. You might create a new model every month, for instance. So the version of your model could be the year and month in which that model was trained. So gcloud AI platform versions create will create a new version. You'll specify an origin, which is where it will go and pick up your trained model. You'll specify your runtime version, which is your TensorFlow version that you used and the Python version that you used. And you'll also specify a project ID, because you might have multiple projects, but you still just need to specify a project ID. And this is what it looks like if you're using the console. So whatever it is that you do from command line, you can do from the console. So you can go on the Google Cloud Platform and just go to AI platform at the bottom and choose create model, and you can give it the model a name and a description. And once you do that, you can then upload a new version. So you can specify that this is version 1, version 2, or version June 2020, version May 2020, version April 2020. Now recall that you can train your models. You can also perform model inference. So If you've pushed your model to the cloud and you've dropped it on AI platform, you're able to do something. You're able to do G Cloud AI platform predict. So you need to specify your model name and your version name. Now, how do you provide the data that you're trying to use for prediction? What you do is you create a JSON file and then you pass that in as your JSON instance. So your JSON file will have a structure that will let you hold all of the features that you're passing in for prediction. So remember that with machine learning, you have features and you have labels, right? Label is what you're trying to predict. So this is how you would perform prediction. Now, this will do your local authentication. But the good thing about this is also very similar to how you would call your model and perform prediction from inside of code. Now, there's always there's documentation for how you would do this from, say, uh, Python or JavaScript or some other language. However, it's a HTTP post that you're doing. So one other thing is the Google Cloud is very serious about security. Like, security comes first. So if you want to test connectivity from a web endpoint outside of Google Cloud Platform, you're going to need to make use of something called the OAuth Playground. So the OAuth Playground will generate your authentication tokens that you will then use for your HTTP requests. However, what I do in production is, after I've deployed my model to the AI platform, I then create something that's called the cloud function. So the cloud function is under the compute section of the Google Cloud Platform, and it is internal to the Google Cloud Platform. So it doesn't require this kind of authentication that we're setting up here. So I make use of cloud functions, and then these cloud functions talk directly to the deployed model. And then these cloud functions, they just expose an API endpoint. And then to that API endpoint, I add my own type of authentication token that I want. And then applications inside of the organization can then call this API endpoint. So what it means is that software engineers are not dealing with the model. Software engineers are able to say, for instance, if what I need to do is pass you three variables, and then you perform your model prediction and send me back a response, they just talk to the API endpoint the way you would talk to a weather API endpoint or a financial API endpoint or whatever. Like, it's an API call, it's a REST call. They just pass in parameters to your REST function and then they get a response. So that's a quick overview of taking models, going from what it looks like when you're just prototyping, when you're dealing with, say, the Estimator API in TensorFlow, and what it looks like when you're going into production. Now, this isn't the only way. This way worked before TensorFlow version 2.0. Now with TensorFlow version 2.0, a lot of people are making use of the Keras API. Unfortunately, I haven't got the documentation yet for productionizing TensorFlow models that are using the Keras API. So I haven't updated this presentation to show you how you would, for instance, manage TensorFlow serving and other things using the Keras API. But as soon as I have that documentation, I'm going to do a blog post on that. But you can follow me on Twitter to see some of my blog posts or to even ask questions. And you can also check out my website. The two URLs actually resolve to the same place. It's just that the one at the bottom is shorter, but it redirects to the one at the top. So I hope this presentation at least showed you what you need to worry about. Clearly, a 30-minute presentation isn't the whole thing, isn't the real deal. It doesn't teach you everything. It's just to give you an idea of what you need to know. So what you should do is go and check out TensorFlow serving and check out the AI platform on the Google Cloud platforms. So that's GCP. So check those two out, read the documentation, and you'll be well on your way to deploying your models to production. Thank you. Have a good day.
Right, you've now made it to the end of this session. Congratulations. Thanks for tuning into the session. We hope you enjoyed it. So just go back to see if you actually gained best practices and all of those things. You can always check back on the video anytime for references. And right, thank you so much for attending. If you have any questions on PML course, you can reach out to us on Twitter, YouTube, Facebook. I'm sorry, not Facebook, our website and everything. Also, like we said, consider supporting the community by buying books from our affiliate stores. We're also working on different ways you can try to support the community through Patreon, GitHub sponsors, and everything, and so on. So please check the links in the descriptions, and you can also tune into our podcast. We have a podcast show where we get to talk to these experts, even aside of get to know them personally, even away from their session. So you can also check our podcast show, links in the description as well. All right, take care, bye bye, and be safe. Cheers.